Hello, my name is Professor Victor Chang, or you can pronounce that as Chang. So I'm very honored to give a keynote for today's presentation. The topic is on the pioneering AI-based data science and analytics, example demonstrations and recommendation for multiple disciplines. As you may know, AI and data science make mega impact. Therefore, it's very important for me to emphasize on the combined impact, such as to present results with big data analytics, AI, and related technologies. I'm going to start with the overview of an architecture, followed by challenges and recommendation. And the detail of my talk will be focused on examples such as healthcare, finance, weather studies, security, social network, and so on. Because it's very important, whatever we do, we then can demonstrate our live example. And then I'm going to summarize my talk with research contribution, discussion, and conclusion. So first of all, I'm going to talk about the technological overview. As we know, that sensors are everywhere to collect the data. So that it's a platform for us to connect to each other and in order to collect different types of data and to use some smart algorithms or some ways to analyze them and to interpret the implications. And of course, all the types of data are in different type of forms and in different types of sizes and different type of format for us to know. And different discipline may have something in common and something being different. And we spend a lot of time and effort to understand how to make sense of data from unstructured to structure and then to a smarter way to analyze them. Of course, there are some AI-based or AI smart algorithms to calculate the best possible ways and to extract the meanings and to be able to work with other fields such as statistics, machine learning, data mining, big data, cloud computing, and predictive analytics. You may have heard all the similar terms, and they can be used effectively. For instance, you can see that the typhoon is the example with the big data analytics that we can run a lot of simulations behind with supercomputers to run lots of mathematical formulas, and then with the input data from the weathers. And of course, now on, with our smartphones, we can connect to different services and they can get different type of data to connect to each other. And our smartphone can be used as a personal device to get all the services and data at the same time. And of course, we then should know different related technologies such as sensors, smart devices, wireless technology, 4G, 5G, mobile, and emerging networks. Of course, we can then do the data science for everyday users because we then can apply what we have learned in other different fields, such as weather studies, such as geo-economics. And then we can also work with other domains, such as GIS, medical, transport, weather, businesses. Before that, we should also know about the data collection, extraction, processing, and analysis as a way that we should feel comfortable to do them and to make sense of data and understand the meanings through visualization, analytics, and also other services. Of course, there are other types of different AIs with a smart algorithm. We should know, we should be able to feel comfortable to apply them. And with the machine learning techniques, with some pattern studies as well, we then can then use the Hapdoop, MapReduce, Spark, Datalake, in order to do the job better and with the security and privacy in place. As you can see that those are the examples with the data that can connect and get extracted. And then with the Internet of Things that can get different types of services all together. And then we can see this is the map of London. The orange is the middle class area. The blue indicates the one with the low income, and the red indicates the high class or high income. So you can see that with visualization, we can understand all the data within minutes. Now, we need to talk about architecture because there are different ways of doing it. There are people who are doing security. So therefore, we have to know the distributed intelligence, distributed systems, and computing, and then you can connect to different types of security, and there are different layers, such as the hardware layer all the way to the middleware and software layer. Therefore, if we follow the security, things will work. Another way to follow is to by classification, to categorize different types of services, and then we then can ensure the data in the algorithms follow accordingly. For instance, for transportation, we then follow logistic, assisted living, mobile ticketing, and so on. Healthcare, we follow by tracking, identification, data collection, and so on. And smart environments with comfortable homes, industrial plants, and smart museums. So we can then go by classification. So now it's important for us to know all the basics, but how can we use them? So first case is on the healthcare. So in terms of healthcare, there are lots of sensor nodes. In this way, we call it for computing nodes, so that we can collect lots of data and then we can process them. For instance, with a wide variety of things, high velocity of data generation means that you have to input data a lot, and then with a large volume. And then after that, we then connect them, and then with the 3 different layers to classify what type of data for what sort of services, so that we can then make things much faster and better. Another way is to use the algorithm, because we know that MapReduce has been for some time. So they are also studied to improve or optimize the performance, or to ensure that certain problems can be resolved in some way. So in my study, what I did was that for MapReduce, we then classify them into 3 steps or functions. So PMap, PMerge, and PReduce. So PMap maps all the data all together, so they are all there. And then with the PMerge, merge all the data there. So all the process outputs are collected. And then PReduce, all the outputs can be condensed into one of your clusters. So that when different types of processing have been in place, then they are then being compressed or summarized into the output. So the output of one process will become the input of the next. Then what we do next is PMap, PReduce, PMap, PMerge, and PReduced. Then we need to do M-fusion. So why do we need fusion? Because when we have different pieces of information, we need to make sense of it. Imagine this is similar to your individual, that with our body features, like your height, your weight, how your appearance is like, and the dresses you have been wearing. M update means that you're going to update the system with whatever you have processed. So M fusion and M update will mean that you then get into one single data with multiple information. So that can be very useful. Then how can we use this? For instance, in the blood clot, that happens with milliseconds. When we have a cut on the body, imagine what happened is that our body try to stop all the blood flowing. So imagine every single small molecule is one data. Then you imagine they are team leaders that to congregate all the data together. So then we have to do a lot of processing, and then when they are come into one big data, then we can be done by M-fusion. Yeah, and so that this algorithm, fusion algorithm, allows all different data to get together at once. So we then can accelerate and optimize, and then we can even do the 360 degrees Celsius, 360 degrees rotation. Then for tumor modeling, why do we have to study? Because for cancer studies, is a study of the malignant and benign tumor. So in our body, there are different types of cells, whether they are good or bad ones, they are fighting on daily basis. So cancer means a normal growth of cells. So they are in different shapes, though mathematically they can be done and computed according to the stage of maturity. So in terms of maturity, it will look like this. Means that they are in a very strong mature state and they are in some unstable condition. But because tumors, what happened was that it is being done by surgery. So it may not be very good for the body with the chemotherapy and radiotherapy. So we study and simulate the growth of the tumors. So that means that this tumor may be in a fully developed stage. In full maturity, of course, nothing is without weaknesses. So there can be some other weaknesses. Some medical researchers, they think that it may not be a good idea to kill all the cells in the body with chemotherapy and radiotherapy. So they can then, identify the weak spots and then let the medicine to attack the tumor, so the tumor shrinks in size. So it shrinks to a smaller size, then they can then perform a better surgery with a lower risk. So our simulation will allow us to know what's happening in the biological body. Similarly, segmentation for brains is to study how we react to learning. For instance, when we are learning new things, especially with dancing or any body movement, our body reacts in a way that we then can adapt them as a voluntary action without thinking, that we can then perform just like reflex. If we are involved in activities that have a strong or intense brain cells, then we have more cells being active on this region. So they also study whether our performance to do better, is it because of intelligence or practice makes perfect or both. So also similarly, learning is about the IQ or the attitudes of learning. Big data analytics with AI approaches and smart algorithm allow us to see what's happening in our brain and how we react to that. And then as a result of the COVID-19, we are under the lockdowns and it brings a lot of inconvenience. But at the same time, AI and data science can be applied together to help us understand with the COVID-19. So with the COVID-19, we then can see that this patient has some infected spots, and there are also some other infected spots with the image segmentation and enhancement, and we can see it's there. So we can use smart algorithms such as the Moore algorithm and Whale algorithm, so that we can then stick to the number of pixels and to see whether it can be done. So if you can see there's some activity there, so it indicates that a certain parts of the lung is being having the attack of the COVID-19. So this also gives you some indication that the patient may be being in a stage of developing COVID-19 symptoms. So the use of AI and data science can allow us to see and analyze the situations with the COVID-19 from patients. So now I'm going to talk about business intelligence and service. They are being used more in financial world. So for instance, we then can compute the prices of all the stocks or all the assets at the same time. For instance, we can then see how they react to it with the time series. And volatility is the market risk, or the risk or that being developed and being acceptable by the market. So then it can also be fluctuating all the time. And then we can also see they can be applied in the stock market. This is the movement of the stock, and this is trading volume, and this is called the band. And then to track the movement so that you then can get a simplified plot. Another way to do this is that you can do this ahead or after. What it means is that before the movement of the stock, you can then make a predictive modeling based on the historical data, the trading activities, and the predictions of the next movement. The other one can be done after, when the movement has been in place. Then you can get a simple plot to represent the simplified movement of the stock activity. And visualization is important because it allows us to see how we can view towards risk. The risk means different thing to different people. So for instance, a new policy is in place. For instance, the new first-time buyer can get an exemption from the housing tax. So when the new law has been in place, at the very beginning, those risk takers may enjoy the benefit, but when there are more and more people developing it, there might be less incentive or offers for you to do so. But then towards the end of the policy, there can be some last minute or late offerings. So risks tend to be higher when there are more people doing the similar things. So then we can also see other examples. For instance, there are also other stock markets. You can then compute the movement of the stocks, and then with the trading volume, with the R-square value to another interpretation of a risk that balance the trading volume. So risk can be high and low depending on the activities of the market, reacting to volatility and the trading volume, and the simplified plot to balance all this. So this is called Bollinger Band. What does it mean? It means that some scientists feel that one is not enough. You have upper and lower limits so that you can then track all the movement, so that all the stocks, or 97% of the stock are within the 95% confidence interval. So then you can also similarly use them before, after. You can use it 15 minutes before the movement of the stock, so that you can then keep track of the movement. You can then do this after, so that you can capture the trend. It's also important for data scientists to capture the trend, so that we know the movement of the data. Then we can also similarly capture the trend for it. Similarly, we can then compute the stock for the Commonwealth Bank of Australia and also other countries and Boeing in the US. So it really doesn't matter which country. If you use the same principle, you will be able to apply to different countries. And at the same time, you can then all my demonstration and research contribution have been published alongside with high quality papers. So you can also see there are also corresponding high quality papers. So this means that there are two types of forces for the stock. One is buy, one is to sell. Every day there are battles between two sides. So what I did was I got the highest and lowest point of the day of the trading. Then the red region means that this is a buffer zone or area of uncertainty. Why? Because if the buy and sell varies too much, the buffer zone or area of uncertainty accumulates. So you notice that there's a trend that when it accumulates to some point, it's going up, but then you will come to a point that things collapse. So you just keep accumulating to some point that it collapses. It's the same thing. Have you noticed that? So when you're on the way up, you keep the movement for some time, but then to some extent, you cannot hold on anymore, it collapses. So it happens on a daily basis, everywhere. So then this red buffer zone allows me to know before a risk has happened or is about to happen, then it allows me to take a better understanding. And it also gives me a warning there can be something happening and be aware of that. So then how can we achieve this? We can then use the optimization to accelerate the speed of the stock analysis so that it then can run things faster. So data splitting, data training, then with a non-stationary data forecasting, and then we go into loops, adjusting the parameters and refining the data, and to the collecting the new data, and the quality of service may drop over a period of time. And of course, the time with or without simulation may make a slightly difference, but then it will help us to accelerate. And you can also see we can apply the same principle to different type of stock. It's very important that whatever we do, we then can apply to different type of stocks. And similarly, what I'm going to talk next is the weather visualization, because every time when I'm doing a keynote for different countries, then I will then analyze the country. So then you know that this thing is live and up to date. So because your conference is based in Algeria, therefore, I feel that I should do this to prove the point that weather computation. So often what we know is that we don't check the temperature of Constantine or the capital of Algeria, but usually what we need to see, preferably, is as a map, and then to map to the city that we're interested in, and then to check the temperature. This is usually what we have seen on the TV for the last 40 to 50 years. So similarly, this can be done with the combined use of AI and data science. We don't have to use supercomputer now, but then what I've done is that I can collect data, analyze them, and then to present the data about 30 minutes difference. So in this case, this is the 1st of November 2020. So in October, I began to do some testing, so to ensure that I will be able to analyze this. But also, as you can see, Constantine is here. So at about 3 p.m. local time, you got around 22 to 23 degrees Celsius. So roughly, you have no idea. And then how can we do it? I have a paper published. But since then, this can be reused for different countries anytime. So then the difference between these algorithm compared to the previous is that there are 3 workers, because sometimes using the improved version of MapReduce function, it may not be able to do the job better. So now imagine I employ 3 workers. So 1 worker is only focused on one major task, and so on. So for the first worker, it focus on the mapped function. The second worker focus on the merge function. The third worker focus on the reduce function. And there is another worker just to look after all the data arrangement. So when you have done the first map function, so then you then also get the result here. Yeah, and then the output of the first step will become input of the next step. So then the fourth worker also then check things according to the the process. So when the first major data analysis or processing has been in place, so the fourth worker can record of it. And then the reduce function works in this way. So then you then have the function for the fourth workers to ensure that this can be done. So how can optimization take place? So optimization take place often is that a lot of data got confused, or they can go randomization. So in this process, it can be the time that may be longer. Therefore, the fourth worker is to ensure that the outputs are all done and get for the input for the next, and to ensure that the sequence has been in place so that the whole process is very organized. So optimization is done through the queuing and execution will take place without further delay. So then by using this example, we can then apply, by using my unique approach to analyze and to present the data for the temperature distribution in Algeria. So you may see the Constantine is here. There's about 14 to 15 degrees Celsius, and it may be giving you the indication. The red colors and the blue colors means that the likelihood to be cooler or hotter. So go back to the previous slide. So you can then see different processors. You read, shuffle, store, check, categorize, and then you give the categorization 11 category from blue to red. So blue means that the weather is more likely to become cooler or stay cooler for some time based on the data analysis and the historical data and the likelihood for the weathers. So then red means that it's more likely to stay warm. So then you can see that now you may know well that Algeria has different type of weather. The north is more like Europe, it's cool. The middle is like the typical Africa weathers, hot, and then it become warmer towards the south. So they may have, generally speaking, 3 types of weathers. So it may be in the north, the middle, and the south. But usually, sometimes there's a mixture. So then you can see that 1st of November in the north is cool. But then some other places are also getting cool. So there is also no guarantee, but because of the desert area tend to be warmer. Yeah, and then further south is very hot. Then you can see the temperature distribution on the on the 3rd of November. Sometimes in order to do or understand the weather analysis well, we have to measure and to analyze the temperature at different time period of the day, just to see whether is it consistent or is it because in the early mornings, in theory it should be cooler, because in early mornings there's no any sun, and of course things should cool down. So you can see that in the north it's always staying cool. So the temperature may be like here is about 12 as the lowest, and Constantine here is about 17 to 19. So it remains in an acceptable range. It may vary, but in the middle, it may also, it be warmer because it's a desert area. And further south, it depends on how south you go, because down here it may be cooler because it is further away from the coast. But also further down is more towards the other part of Africa. So then you can see that in the north it's pretty much the same. At different time dates. From 10:30 to 9 is still about 16 to 18 degrees Celsius. So then you can have a clear understanding how weather has changed. But when it comes to the following day, even on the 1 a.m., the temperature didn't fluctuate a lot. In fact, it became cooler. It's about around 10 to about 14 degrees Celsius. At the same time, then Constantine became very much cooler when time went by. It went below 8 degrees Celsius, became very, very cool at the time. But when you go further up, it may be warmer. So even within the region, it may vary. You may sometimes feel, hey, how come the other town is warmer? And with about 5 degrees Celsius different, you can also feel that. So sometimes it's unexplainable why it's cold or it's cool. But then it may be because of the wind, the warm wind or the cold wind. So you may know that the Constantine area and the capital of Algeria, there's a difference. The difference is that on the 6th November, 3 a.m., the capital city is warmer, is above 22 degrees Celsius. It becomes very warm. Perhaps it was the wind from the ocean brings some warm air, but it's not going far. But because of some cold air from other part of Europe, stay here. Yeah, so in a Constantine area, so you may have a temperature of about 12 to 15, whereas here is about 22. And then at about 7 p.m., the temperature doesn't change a lot. Then the capital of the Algeria still warmer, but it's become cooler. And the Constantine is still a little bit cold, but it's getting the warm air. In the south, you may see that it is warm, but also different part of south also behave differently. Here is cooler and here is warmer. So even in the south, it's not a typical south weather. You may see there's a divide. So it actually help us to understand a lot. So you can see the following day with the 8th of November, you can see the temperature change. And it was a bit cool, about 13 degrees Celsius, but then down here it's become much warmer. And then you can also see on the 8th of November, 5:30 p.m., there is around 8 to 10 degrees Celsius for Constantine. But for sometimes the warm air just got trapped. So sometimes at the time of doing data analysis, some part may become a little bit unusual. So then we can then see further on the 9th of November, 5:30 a.m. And Constantine was a bit cold. There was about 8 to 10 degrees Celsius, but then warm air came in. But then warm air seemed to go into the land rather than staying on the coast. So sometimes it is not easy to track the movement of the air. And then when it came to 11th of November and 12th of November, sometimes comparison could be done, with around 1 day difference to see whether there's any different outcome. And you may see that in the early mornings, the Constantine may also go to about 12 to 15 degrees Celsius. And similarly, even on the following day, doesn't have a lot of change, a lot of changes, except maybe it's cooler around the coastal region. And then sometimes we can use the same principle to apply to different countries. We can see that on 13th of November, that you can see the weather here, it was becoming cooler. There was about 8 to 10 degrees Celsius. So I have done around 2 weeks of analysis for Algeria. And then October is for processing and development. So you can see that in the north is pretty much cool, but in the middle part is quite warm. And then south have different type of weathers. And we can apply the same principle to show there's in Italy, on 26 March of 2017 is very warm. So especially in the southern part of Italy. And then I also did a keynote for Kazakhstan. So you can also see it has a very typical weather is very into the land, and then it varies a lot. So the Almaty is having about 16 to 18 degrees Celsius. I also did a keynote for South Korea. So the Seoul was very cold in the autumn period. It was about 15 to 16 degrees Celsius. You know, it's 1:30 p.m. And it's just unexplainable. In the south, it's very warm. So it was probably with some cold air blowing from Russia to North Korea to South Korea. Then we can also do the same thing, you know, for other countries such as the Sydney, to show that the temperature fluctuation, especially in the January period, it just fluctuated a lot because there was the summer period of Australia. You can see that the temperature also went a lot. It was because of some bushfire, so they were changed significantly. And then we can then use the same principle for other discipline. One example is social networks. So social network initially was out of curiosity. I want to show how it works with other services. But because of the shortage of time now, so I may also come to a little bit later. So now the next thing is the security service, because we know that a lot of data, a lot of users need to ensure that they are in a very secure place, so that they will be having a robust and resilient environment to work with. So in 2015 and 2016, I developed a multi-layer security based on my previous years of experience, which means that just one type of security is not enough. We have to have integration of different types of security services. Imagine there's only one goalkeeper. How about if there are 3 goalkeepers at different stages? It might improve on the security. And then the multi-layer security means that the first layer is being access control firewall, and there are some unique IP tables to ensure that everyone to get to different type of access at different type of privileges. The second layer, we have the identity in layer, which means that intrusion detection and intrusion prevention, to ensure that any abnormal activity can be detected, and then we can set rules to identify. If it's not authorized, then we can kick off. But even so, there can be some other vulnerabilities in place, because for instance, for encryption, if it's not doing well, then we may see that some data can be, as a fake or being compromised, and even went through this. It's similar to COVID-19. It's just that our immunity has been compromised. So encryption with some smart algorithm will identify those fake guys. And then this is the principle of multi-layer security, to ensure that all the data and all the users have been in place and has been checked by 3 different layers of security. So they started with my job as an IT manager in London. That's back in 2010, and then I also have some experience before managing 500 servers in a data center. So usually data security, we have lots of terabytes and petabytes. We cannot just know where to fix. We cannot just do it. We need to know how long it will fix, how much resources we need. So data can be in 3 types: in use, in rest, motion. So then we check with security, and then we then have analysis. So we then, with this simulation before the rescue action took place, because before we then can spend time to rescue the data, rescue the server, rescue everything back, we need to know how much time. So you then computer to have 125 hours or slightly over that. So we have to rescue everything within 125 hours. So ethical hacking is important, because what we did was that we replicate the server, replicate the environment, and we did a lot of virtualization. We then created another virtual data center with a physical data center to ensure that if things broke, what we would do. And we then injected with the Trojans and viruses of the previous year. Of course, we already knew how to fix it, but then it means that your current security got to be robust enough to withstand all types of attacks. So you have to constantly, get a lot of different tests for the system. So you could also have two teams. One is to defend the system. One is to attack the system under the ethical hacking condition. So even everything broke, you could just wipe out everything through the virtualization or virtual data center. Then we tested that under 125 hours, our multi-layer security could block all the attacks. But then the performance went down over a period of time. So from nearly 100% all the way to below 80%. And at the same time, the execution time for the simulation was fast. Within 2 seconds, we knew how much we needed to know, how long it would take. But then at the same time, we test the performance of a multi-layer security with 3 layers with firewall, identity, and encryption. So firewall could go above 5,000. So we injected lots of viruses and Trojan. The first layer could block more than 50%. Let's say there are 100 or 10,000 of them, so it was like 55% performance. And then identity layer, so because we wanted to perform the intrusion detection and intrusion prevention, so then it then could block about more than 3,000. And then encryption algorithm allow us to identify the fake guys, the compromised data, the compromised things, so that it then block another up to 900. Then there is about 3 to 4% that we could not remove or kill. So we could then successfully isolate them. We isolate them, and then we could wait until a better opportunity to remove it. So before 2012, it was a turning point because a lot of security was only based on one solution. So our multi-layer security would be much better than that. So it was better than the security used before 2012. And since then, a lot of security has been in the development of integrated services. So then this is the social network which I have talked about. Due to the time constraints, so initially I use Facebook data just to show that the work in my networks and relation with my families and friends in Taiwan and Singapore. But you notice that we didn't talk a lot on Facebook because we talk more on the real life or on phone. And my friends in Australia, they are very well connected. The circles means that how influential you are to the group, and also the classmates in Singapore. They also talk frequently. So the links means that the strength of the network. So there was a stage I worked in different parts of UK, in Southampton, in Leeds, and in London. So people in London, they are more dispersed. So they are in different parts of London. It was a greater area. And then in Southampton, they were talking and working on a daily basis. And people in Leeds also have similar patterns. So through me, then you could then connect to different people. Then there are also other languages to see how people reacted to your messages or your blog. So contact who commented without clicking like, contact who commented but also clicking like. So this is just a demonstration to know who were the people doing what, because there are a lot of people that they might not actually comment, but they observe you. So those languages would allow me to know. But at the same time, this is the a place that when a big event happens, such as the death of celebrity, or the UK have decided to leave EU, and also the US presidential election, the circle means a different community of different people, and links means a lot of communication. You talk to lots of strangers you never knew because of big events. So all the big event happens, or the Black Swan event happens. It's always like that. So there are also other services, such as the education as a service, that we can teach our students how to use, the data mining, visualization, and programming, and statistical analysis. So we can compute all the data at the same time, and that's very useful. And at some time we can then blend the business model with the infrastructure platform and software service. So this can be used as a consulting for IT business, or even for cloud, IoT, AI, big data adoption and integration. It's a very important thing. We sometimes call it ABCD. A means AI, B means big data, C means it may mean cybersecurity or cloud, depending on your emphasis. D means that you are using the data analytics. So they can be B. Sometimes for some people means blockchain. So ABCD technology. So we can also use the same principle by blending both AI and data science, because in my talk, the emphasis more on AI and data science that can be applied to different disciplines. So in this case, this is the GDP for 2016. So now you can see that if UK has decided to leave EU, it may have an impact to the EU economy, especially in the COVID-19. Now the crisis happened and a lot of GDPs and a lot of economic indexes will go down. So in this talk, I have demonstrated the examples for different disciplines. So first of all, I explain the important concepts and the fundamental principles. I also explain the algorithms behind, and then I also explain how can I apply this principle in different disciplines. So that include the healthcare, include the business intelligence, that include the weather studies. They also include security, and then social networks. So these are just 5 examples of my research. There are also other examples. Due to the limitation of the time, I may not be able to talk. So in summary, I have shown the successful proof of concept, deliveries and services to help people, and then to provide recommendation and support, and so that you can see there are also IoT, cloud, big data adoption framework that can be applied in a lot of disciplines. So once we know all these, we can then apply in different disciplines. And of course, there are data fusion and integration of different types that can be used for current and future work. And we can apply the same principle to different disciplines. And of course, all these will lead to lots of publication, awards, and excellent R&D outputs. So if you have any question, please email me. I have different emails, but preferably I use the Gmail for different research communication. So this is the Gmail that I've been contacted with you and the event organizer, but also I've used Gmail. So I have worked with different journals at different period of my academic career, and so that I have a big knowledge, and also I have a good understanding of what each journal would like. So if you have any question, to let me know. My current focus is more towards funding, so I'm always look forward to any collaboration. So I really wish you to have a good time. If you have any question, please let me know. I will be very willing to answer you. And I shall leave my talk here. It's very important that we then can take any messages and then have a possible conversation that may lead to collaboration. Thank you so much for your time. I really appreciate it. Thank you. Have a good time. Bye.